Hello and welcome to Erroneous, your post-film study session with John, the scientist on the show. Hello John.
Hello, John.
A random gravitational field, a forgotten law we won't let anything slip by. And this week, John, let's focus on Star Wars.
And I start with this scene from Star Wars, The Force Awakens, which is absolutely not rigorous. Look, John. Here, Starkiller is firing its laser at planets. The laser seems to follow a straight trajectory visible in space.
Yes, indeed.
However, in the vacuum of space, a laser is invisible until it reaches a surface or particles capable of scattering or reflecting light. According to Albert Einstein's general theory of relativity, the presence of mass and energy curves space-time and influences the motion of objects. This also includes the propagation of light, here our laser, which should be partly attracted by the gravitational fields of stars or celestial bodies along its path, which doesn't seem to be the case.
So, if we could send a continuous burst to a planet from Earth, we would observe a bright spot on it and not its entire trajectory, at least if we manage to pass through the various gravitational fields.
But I'm not done. A laser travels at the speed of light, but whether it's Kylo Ren in his ship, Finn or the population of Coruscant, they all have time to observe the disaster that is visible here, moving for a few seconds. However, lasers travel that trajectory at the speed of light. The distance between Starkiller and the planets doesn't seem gigantic, so they would have exploded in an almost instantaneous duration.
But they wouldn't have time to be scared.
Not wrong. We can also observe this phenomenon with the X-wing laser cannons, this time with a shorter propagation duration and still with the issue of fire and sound effect.
I was wrong.
No big deal, but be careful next time. While we are on lasers, let me show you another one, taken from A New Hope.
I see. The lightsaber laser can't stop if it doesn't reach any surface.
Exactly, John. Here, nothing should stop the propagation of the laser, and we are not dealing with gas, so put away your UV lamp.
You're being bitter today, John. It's probably a Star Wars specific energy that can work miracles.
The Kyber crystal? That must be it. Let's move on.
Here, the explosion of the planet has a fiery appearance that persists in space.
Easy one.
Totally.
This does not reflect the physical reality in the vacuum of space.
Yes, here there are no atmosphere containing air to support combustion like on Earth.
I won't let these visions come true, Master Yoda.
You better. The planetary explosion could release matter and energy in various forms, producing intense light and radiation resulting from the mix of kinetic and thermal energy from the planet. But without oxygen to fuel a fire, and the resulting debris would be propelled in various directions like a supernova.
For this last point, we can support George Lucas' representation.
Totally agree. But there's something else.
I know. There can be sound in space.
Absolutely, John. Let's analyze this phenomenon more closely. We know that the speed of sound varies according to the density of the material. For example, in the air it's about 340 meters per second. In water it goes up to 1500 meters per second, and in steel it reaches 5 kilometers per second. However, in interstellar space the density is very low, 1 particle per cubic centimeter, so sound cannot propagate, explaining why we can't hear sound in space.
Once you know it, it's really obvious.
You have no idea. Let's move on to the next scene. Here, the Empire is heading toward the planet to face the rebels. Did you notice something, John, regarding the reactors?
They're on. What's the problem?
Well, if I was a pilot, I would have turned them off.
Why?
In space, all we need is a nudge to move at a constant speed.
I see what you mean. It will be enough to activate them long enough to reach our cruising speed and then turn them off to save intergalactic kerosene.
Exactly. Especially since fuel is expensive right now. Han Solo knows that.
10,000, all in advance.
10,000?
However, if you want to change course, you will have to use his engines to apply a force that will change in state of motion.
John, maybe they are keeping the reactors on to create gravity in the ship. I know that artificial gravity is often present in spacecraft in movies. But to create it, you have to maintain rotation or acceleration, a bit like the water seal we spin around us during our childhood.
I still do it, John.
Okay, that works, John. So in Star Wars, maybe they have the technology to achieve this.
In that case, I'm sorry, John.
Apology accepted.
Thanks, Darth. Let's continue.
Alright, stand by.
I've always found these journeys aesthetic.
Aesthetic maybe, but not conforming to reality. Scientists have managed to represent what we would see during journey at the speed of light, and it wouldn't look anything like this light trails.
How then?
Well, at such a speed, All the light rays from the stars in our field of vision will group together into a patch in front of us that will resemble blue, and everything behind us will darken.
Why?
This is again due to the curvature of space-time that will influence the light rays from stars. Those from the stars in our field of vision will deviate into a clearer patch of light proportionally to our speed. That's the phenomenon of aberration of light. The rays from those behind us will increasingly struggle to join ours, which will tend toward theirs, making it appear redder and darker. That's the Doppler effect. All of this, of course, if we could reach this speed, which is far from achievable. Sorry, Darth.
So, if we summarize, the cinematic representations of vehicles, weapons, destruction and journeys in Star Wars are exaggerations that don't exactly reflect scientific reality and are present only to make the scenes more memorable and spectacular.
Luke, you're going to find that many of the truths we cling to depend greatly on our own point of view.
Well said, Obi. Although designed for visual and dramatic reasons, let's be honest, they are much more enjoyable on the big screen.
That's for sure.
I'm done, John.
Well, thank you, John. It's the end of this show.
We'll see you very soon for a new Erroneous.
And there will be science. Lots of science.